In this class, we'll discuss about introduction to surface chemistry. What is surface chemistry? What topics will be there in this? What to study in this surface chemistry? Let me discuss. So first of all, we'll see what happened. So when you observe here, what happened? Why does water stay on the surface of the leaf? Why, if you look what happened, water droplets on the surface of the leaf of plant, it looks something like this. Why it is staying like that? Why it looks something like this? Next thing, if you observe, why water soaks into tissue paper? For example, if I take a tissue paper, now water is soaked here. Okay, but in on the leaf, if you observe what happened, it is staying on the surface as a drop like that. What is the reason behind this? That we'll discuss here in surface chemistry. Now, why does fog is forming? This is fog. Why does fog is forming? We'll see that one. In coffee, where foams come from? This foam is coming in from coffee, no. Where it is come from actually? Why this is coming actually? Why this foam is coming actually? Let me see in surface chemistry. After studying this chapter, you will be able to answer all these questions now. Let me see now this one. Surface chemistry, the chapter named surface chemistry deals with the phenomena that occurs at interface of two phases. What is the phenomena is occurring between the two phases? At what interface which is present in the two phases actually? What is the two phases? What is the interface? Let me see. The bulk phase that we come across in surface chemistry may be pure compounds or solutions. So wherever we see bulk, major amount of phases that we come across here, there are pure compounds or solutions. Second point, the interface is normally a few molecule thick, but its area depends upon the size of the particles of the bulk phase. So this interface is normally a few molecules that thick, but its area depends. They are thick only, but the area depends upon the size of the particles or bulk of the phases. Now, surface chemistry deals with the phenomena that occurs at interface of the two phases here. See, interface of the two phases. What are these two phases? Let me see now here. Adsorbate and adsorbent. Let me see that one. Let me take only this interface of the two phases. Adsorption phenomena. Let me see what happened. Adsorption. The surface of solid has the tendency to attract the retain the molecules of the phase with which it comes into contact. So the solid surface will have a tendency to attract or retain the molecules of the phase with which it come in contact. For example, if you see the pencil I have taken here. Accumulation of molecular species at the surface rather than the bulk of solid. This is called definition of adsorption. Now, what is the meaning of this one? Concentration or accumulation of several type of molecular species at what phase on surface? Rather in the bulk of a solid or liquid, in this is called what? Adsorption. Now you observe here what happened. This is actually surface. Surface. Now what happened here? Some molecules are concentrated, accumulated on the surface of this adsorbent here. Now you are calling this phenomena is called what? Adsorption. So the molecules or species are accumulating, concentrating on the surface. You see, observe here what happened. Accumulating over here. See. Now what is adsorbate and what is adsorbent here? On which surface this phenomena is taking place? On this surface the phenomena is taking place. Therefore, this is called what? On surface this phenomena is taking place. On which surface the phenomena is taking place? On which surface the phenomena is taking place? That is called what? Adsorbent. That is called what? Now, what molecules are adsorbing? That molecules we are taking as adsorbates here. And the phenomena you are calling as adsorption. You see, these molecules, these are the molecules, are concentrating over the surface here. And the surface you are calling as adsorbent, and the molecules which are concentrating you are calling as adsorbate here, bait and bent, right? Adsorbate. This one will be the adsorbent. Will be the examples. What type of examples we can take? What type of surfaces we can take for what? Adsorbents. Charcoal is the best example because charcoal is adsorbs, isn't it? Air, isn't it? Charcoal is the best adsorbent generally we'll take here. Charcoal. Best adsorbent. Best example we can take. Silica gel, generally we see in the refrigerators here. Silica gels, which absorbs the moisture. Silica gel absorbs the moisture. So charcoal, silica gel can be taken as what? Adsorbent. Similarly, what happened? Alumina gel also can be taken as what? Adsorbent. Clay also can be taken as adsorbent here because it also absorbs. Metals in what? Powder state. Finely divided state, powder state here can be taken as adsorption state. So in the preparation of ammonia, we'll take iron as a catalyst in which it will adsorb what happens, nitrogen, hydrogen gas, and chemical reaction takes place to form ammonia. So what are the examples we have taken for adsorbent? Charcoal, silica gel, alumina gel, clay, metals in finely divided states are taken as adsorbents. Accumulation of molecules at the surface of the solid or liquid is called what? What type of thing we can call? It is called what? Examples of adsorbents. So all these are what? Examples for adsorbent. Charcoal, silica gel, alumina gel, all comes under adsorbent only. Next, adsorption in action mechanism. If you observe what happened, let us understand adsorption with some examples now. If gas like oxygen, hydrogen, carbon monoxide, chlorine, ammonia, sulfur dioxide is taken in a closed vessel containing polar charcoal. Now this charcoal is now adsorbent, and these gases can be taken as what here? Adsorbents. Closed vessel having what? Charcoal here, we maintain zero pressure in this case. So we are placing some adsorbents here. Adsorbates here. This is adsorbent. And you are placing what? Adsorbates here. Now what happened here? After some time, the pressure in the vessel decreases. It happens due to the adsorption of hydrogen at the surface of the charcoal actually. Because hydrogen will have some pressure. So what is happening? These hydrogen gas molecules are concentrating or accumulating on the surface of the adsorbent called charcoal, and hydrogens are the gases are now converting into they're changing their nature actually. They're changing their phase here. So that is the reason what happened. The pressure what happened decreased. So it indicates when pressure is decreased, what happened? Hydrogen molecules are accumulated. The number of hydrogen molecules are decreased here. So you can say this is got. Example 2, if you take in a solution of an organic dye, say like methylene blue, when animal charcoal is added and the solution is well shaken, it absorbs that the filter rate turns into colorless. That means organic dye. Which organic dye I have taken? Methylene blue I have taken. So animal charcoal is added and the solution is now will shaken. Now solution, what happened? Convert into colorless because the dye which are giving some color absorbed by what? Whom? Charcoal. Now charcoal is here adsorbent. Organic dye is what? Adsorbate here. It is what? Bait. Now adsorption phenomena took place here. See, this is the methylene blue. Now what you have taken? Adsorbent you have taken. Now what the color particles, whatever the particles which are having in this one, the colored particles we are having here, no, we are calling as adsorbates actually. Now they are concentrated over here. Now that is the reason what happened. It become now whatever the colored particles which are adsorbates concentrated, accumulated over the chart. One more thing, you can take aqueous solution of raw sugar. You can take raw sugar. When passed over beds of animal charcoal, they become colorless. The coloring substances which are present on the raw sugar, that whatever the colored sugar the colored substances will be adsorbed over the charcoal. In this way, we can purify the raw sugar also. Example 4, if you observe, the air becomes dry in the presence of silica gel because water molecules are absorbed by whom? Silica gel. Now, water is becoming here adsorbate and silica gel is becoming here adsorbent. So, which phenomena is taking place here? Adsorption process. Now, here, one more thing, if you observe, the process of removing the adsorbed substance, opposite to what adsorption is called what? Desorption here. When you remove whatever the adsorbates present over the adsorbent, then that process is called what? Desorption process. Gases like oxygen, hydrogen is taken in a closed vessel containing powdered charcoal. It is observed that the pressure of the gas decreases. So what is the phenomena we observe here? Adsorption phenomena. The process of removing an adsorbed substances from a surface on which it is absorbed is called absorption, right? The differences between the adsorption and absorption. Difference between the adsorption and absorption here. And what is the mechanism involving in the adsorption? That we'll discuss now. First of all, what are the differences between the adsorption and absorption? Adsorption, that adsorbate molecules will be concentrated only on the surface. Only on the surface. They do not penetrate into the interior part of the adsorbent. Only on the surface. This is a surface phenomena. Only on the surface it will take place. But in absorption, it is uniformly distributed throughout the whatever the substance is there. It will distribute into the even interior part also will be distributed. This is a bulk phenomenon. That means complete phenomena. It is only surface phenomena, isn't it? Example, I have taken a beautiful example. I am taking chalk, which is white color, colorless. I am putting over in the ink like this. I am keeping the chalk in the ink bottle. Now, definitely it will be. It looks what happened? Blue color. If I put that in the blue ink, definitely it will look like blue color. Now, in this case, when you break that chalk, okay, now what is happening? The surface of the chalk, only the surface of the chalk is retaining the color of the blue color. And you are calling this one adsorption process. While the solvent of the ink goes deeper into the stick due to absorption. So now when you break, after just keeping the chalk into the ink bottle, immediately remove that one. Only on the surface the chalk will have the blue color. When you break that one, the interior part will have colorless only. The phenomena is what adsorption. But if you keep that one for long time, what happens here? The blue color will move deeper into the chalk piece. So that process we are calling as absorption. In that case, when you break, what happens? Entire thing will be in blue color only. So if you observe this one, definitely you can easily remember this one. So the process in which both adsorption and absorption can take place simultaneously, absorption taking place, adsorption taking place. They are called what? Sorption. That is called what? Sorption. Okay, both are taking place simultaneously. Then that process is called what? Sorption. Example, a gas on the zeolite. If you take any gas over the zeolite, sorption will take place, absorption will take place. Both are taking place. Now let me see the mechanism of adsorption. Adsorption arises because surface particles of adsorbent are not surrounded by atoms of molecules the same kind on all sides. And hence the process, it possesses what happened? Unbalanced or residual attractive forces which are responsible for attracting the adsorbent. What is the meaning of this? Now they cannot be surrounded. Whatever the molecules of adsorbate cannot be surrounded completely over adsorbent. That means they are not going depth. In deep, they are not going. In that case, what happened? Their interactions, the attractive forces will be what? Unbalanced. So let me see this one in a beautiful example like this. Now I have taken, see, this is surface, this is the surface. Now some of the molecules are adsorbed over here. In above, they're free, they're free, they're free. So here it is downward direction, what happened? They're attracted here. By what happened? Whatever the under molecules are there, they will be attracted here. But what about the top molecules? So here we don't have any attractive forces here. Top, what happened? We don't have any attractive forces here. Unbalanced forces I'm calling it. Unbalanced forces. Okay. So let me see this one. During adsorption, what happened? There is a decrease in the surface energy which appears as a heat, therefore it is exothermic process. So whenever if you observe here what happened, adsorption is taking place, definitely the surface energy will decreases, and whatever the decrease in the surface energy will appear as a heat. So releasing of heat is definitely called exothermic, and delta H equal to negative. All adsorption process all will be exothermic process only. Now why this decrease in the surface energy takes place? Let me discuss now. Now this is what actually on the surface the blue particles are adsorbing over the surface. The yellow is called nothing but adsorbent, and the blue part is nothing but called adsorbents. Actually, the phenomena is taking place adsorption process. Now in this process, what happened? Heat is released. You observe the heat is released. So you are calling it one an exothermic process. Now this. So for example, adsorbate is a gas molecule adsorbed on the surface of what? Something what happened? Charcoal. The charcoal is adsorbent. Now adsorbed, the gas molecules are adsorbed. Now what happened? The freedom of the momentum of the molecules will be restricted. Means what happened? So when they absorb, you see, observe again, you see, you observe. Okay? Now they are actually free actually. Now when they absorbed on the surface, what happened? They fixed on the surface of the surface. Now that means they become almost all solids now. Here. They become almost all solids now. Here. The gas particles are converted into solid like that. Isn't it? So in that case, what happened? They lose whatever that energy, because gas will have more energy. And one more thing, gas will have more entropy. Gas will have more disorder. So when they adsorb on the surface of what? Adsorbent, they are becoming order now. They are losing their what? Disorder. Now they become order now. Then entropy will what happen? Decreases. Now delta S will become negative. Delta H is what here? Exothermic process. Negative here, isn't it? Delta S is negative. Delta S also what? Both are what? Entropy is negative and enthalpy also negative. Both are what? Decreasing. Entropy is decreasing. Enthalpy also decreasing. Adsorption is a spontaneous process, but whenever you see, when delta S is equal to positive only, we can say it is what? Spontaneous process. But even though delta S is negative, the gas converting into what here? Something what? Solids like that. You saying something it is should be non-spontaneous. If delta is negative, it's non-spontaneous. But adsorption is spontaneous process. Why? Because when you take Gibbs energy account 11th class, delta G is equal to delta H minus T delta S. Now substitute your delta S value here. The delta G you are going to get will be negative. Because in this process it is negative, negative, negative into negative, minus, minus into minus, plus, this value will be positive. Of course, this value will be negative only, but this value, if it is what more value, if this value is more value, if positive is more value, definitely delta, no, sorry. If this is not negative value, if it is whatever positive into positive, negative into negative become positive, if this value is more, if this value is more, what happened? Definitely delta G will be negative. So why Gibbs energy is negative? Because this value is what more negative, even though what happened negative into negative, positive, we get what happened, delta G is getting negative. Delta H is possible when delta H is more negative, what happened? Definitely what happened? Delta G will be negative. Okay. Now, as the adsorption proceeds, delta H becomes less and less negative. Ultimately, delta H becomes equal to delta T delta S, and delta G becomes 0 here. At this state, we get equilibrium. So whenever what happened, delta H is decreasing, getting less negative values. In that case, what happened? Both will be equal, and the resulting delta G will be 0, and it states that it is in equilibrium. The uniformly distributed substance throughout the bulk of the solid is called what? Absorption process. Throughout is called absorption. Absorption is accompanied by what process? Decrease in enthalpy, decrease in entropy. Both are what happen? Negative only. So this is about the adsorption and process.